Today, we are decoding Mr. Safety's treasure locks. We are doling out free pizza. We are devising a very simple card game. And then, we are scoring a game of blackjack. Hello, world, and we are dealing with games-themed katas on today's episode of Versus Codewars. And I hope everyone is having a wonderful and safe day today. We begin today's warm-up segment with a function that takes a string which has integers inside it separated by spaces. The goal of this kata is to take that string of integers and convert each integer of that string into an integer and return those integers sums. Let's go ahead and get started with this one here. And what we'll go ahead and do, const Summy. And we'll have our string of integers here. And what we're going to do with that string of integers here is first we're going to go ahead and split that. Split that into its individual integers with a space separator here. And we're going to run each of those integers through the reduce method here. And we're going to have our sum here and our int string right here. And we're going to return that sum plus, and what we're going to do a little bit of a trick here. If we prepend a plus sign to our int string, JavaScript will attempt to implicitly convert that string into an integer. And in so doing, we should have the sum of each of the integers given in our string here. Let's go ahead and test this out here and see how that works. Do Summy, and we're going to have our string here. And that string is going to contain the integers 1, 2, 3, and 4. Alright, let's run that through Node to see what that looks like here. Node warmup Summy. And we get the integer 10 as a result. I'm going to go ahead and zoom in so you can see that well. Alright, I'm going to go ahead and zoom back out here. And we're going to go ahead and punch this into Codewars to see what this looks like here. I'm going to go ahead and hit attempt, and we are good on that. For our next warm-up kata, the Arara are an isolated tribe found in the Amazon who count in pairs. For example, 1 to 8 is as follows. 1 is Anane, 2 is Adek, 3 is Adek Anane, 4 is Adek Adek, 5 is Adek Adek Anane, and so on and so forth. The goal of this kata is given a number, return that number's Arara spoken representation here. Let's go ahead and get started with this one here. And what we're going to go ahead and do, const count Arara, and we're going to have our number right here. And what we are going to go ahead and do is, I think we will go ahead and do a while loop here. I'm going to do keep track of a result string here. We're going to return that down here. And what we're going to go ahead and do, we're going to do while number is greater than 0 here. Or maybe reps greater than 1. And what we'll go ahead and do is we're going to do results plus equals Adek. That might be better off as an array here. That's result. I'm going to set that equal to an empty array. We do results.push. We're going to push in the string Adek here. And we're going to do number minus equals 2. And this while loop should continue as long as this number is greater than 1. And then at the end here, what we're going to go ahead and do, if number is equal to 1, we'll go ahead and return results.push anane right here. And then finally, what we'll go ahead and do, we'll take that result array and join that together with a space separator here. All right, let's go ahead and test this one out here. We'll do a console.log 1, 2, 3, 4, 5, 6, 7, 8. We're going to run that array through map, and we're going to pass each one through the count function here. All right, let's go ahead and test this out here. Node warmup Amazon. And we get our array of strings containing the Aurora representations of our numbers here. All right, let's go ahead and punch this into Codewars to see what this looks like here. I'm gonna hit the test, let's hit attempt, and we are good on that. For our next warm-up kata, imagine there's a big cube consisting of n cubed small cubes, n cubed being n times n times n. The goal of this kata is to calculate how many small cubes are not visible from the outside of this big cube. For instance, if we have a cube which has 4 cubes in a row, the function should return 8 because there are 8 cubes inside of our cube. 2 cubes in each dimension here. Alright, let's go ahead and get started with this one here. Const not visible cubes, and we'll have our row cubes here. And what I think we'll go ahead and do, if we had a cube that has 4 cubes in a row, then the function should return 8 because there are 8 cubes inside of our cube, 2 cubes in each dimension. First and foremost, if our row cubes is less than or equal to 2, then we should return 0. Because in a cube with 2 cubes in a row, all of the cubes therein should be visible. Alright. Otherwise, what I think we'll go ahead and do, we ought to be able to just return row cubes minus 2 raised to the 3rd power here. Right, feeding this through console.log here. Not visible cubes. Let's pass in that 4 here. We should get 8 cubes here. And in fact, we do. Let's go ahead and punch this into Codewars to see what this one looks like here. And we are good on that. For our next warm-up kata, we are dealing with centered strings. Our computer got infected by a strange virus. It only infects my text files and replaces random letters therein with an asterisk. Something like what you see in the kata instructions right here. Fortunately, I discovered that the virus hides my centered letters inside the root directory. It'll be quite tedious to recover all these files manually, so the goal of this kata is to implement a function that will do the hard work automatically. So, go ahead and type this in right now. Our kata solution is going to have a couple arguments here. The censored strings, and then the censored letters. And the goal of this kata will be to use the censored letters to fill in the asterisk in our centered string and return the original string. Let's go ahead and hit train. And what I think we'll go ahead and do, we're going to do while. I think we'll go ahead and try splitting our censored letters into an array here. Yeah. And then what we'll go ahead and do is do while. I think we'll go ahead and do that same thing with our string as well. And then while censored string dot find, or rather find index, or rather index of. I wonder if that even works in an array here. I probably don't imagine so here. So what we'll go ahead and do, while censored string dot index of, the asterisk is not equal to -1. Then what we'll go ahead and do, we somehow need to place our censored letter into this string right here. What we'll go ahead and do censored string equals censored string dot replace. We'll replace that asterisk. Wait, I have a better idea. Instead of finding the index of the asterisk, how about we do while censored letters dot length is greater than 0. And then what we'll go ahead and do in our while loop here, we'll do censored string equals censored string dot replace, or replace our asterisk with the return value of censored letters dot shift. So this will call the shift method on the censored letters array. The shift method will pop the first element from the array and return that element here. So what we're going to go ahead and do, if we supply a string to the replace method here in the string object, it will replace only the first instance of this particular substring in that string. We should be able to keep doing this as long as we continue in our while loop, while the length of this censored letters array that we created up here is greater than 0. What we should be able to go ahead and return our censored string now. Alright, let's go ahead and test this out down here. Console.log. Let's grab these arguments here from one of the examples in our Kata instructions here. And let's go ahead and test this out here. Node warmup censored. And we get the original string. This is very strange. Now, what if we supplied an uncensored string and an empty string for our censored letters? And we should get the original string right away. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And let's hit attempt. And we are good on that. Finally, we are aerial firefighting. We are an aerial firefighter, someone who drops water on fires from above in order to extinguish them. And our goal is to work out the minimum amount of water bombs that we need to drop in order to fully extinguish the fire. The fire department has budgeting concerns, and we can't just be dropping tons of water bombs. We need that money for the annual Christmas party. Given a string representing a 2D plane of random length consisting of two characters, a lowercase x representing fire and an uppercase y representing buildings, The goal of this kata is to return the minimum number of water bombs it would take to extinguish the fires in that string. Let's go ahead and get started with this one here. Const water bombs. We'll have our fire string and the water bomb width here. Our water bombs can only extinguish contiguous sections of fire up to this given width right here. What we'll go ahead and do with that being said, first I think we'll go ahead and keep track of our water bombs used. Set that equal to 0. And this is going to be what's returned. And then, I think what we'll go ahead and do, while fire string length is equal to 0, is greater than 0 here. Then what we'll go ahead and do, I think we'll try using the index of method to look for the first instance of a building. We can go ahead and keep track of that variable up here. Let next building index equals -1. We'll do next building index down here. We'll set that equal to fire string dot index of our building, which is going to be represented by the capital Y. And then if our next building index is not equal to -1, which would indicate that there is in fact a building in this fire string here, and the next building index is less than our water bomb width, then what we'll go ahead and do, we are going to go ahead and we're going to do fire string equals, we'll do fire string dot splice. I think the string method does have a splice method. String object does have a splice method here, right? Let's go ahead and hit up the node repo here. And splice. No, string does not have a method called splice. So what we'll go ahead and do, we'll do fire string, we'll set that equal to fire string dot slice. The string object does have a method called a slice. And what we'll go ahead and do, actually we'll go ahead and actually use the substring method. No, yeah, we'll use slice. And we'll slice from the next building index +1, I think. And then otherwise, what we'll go ahead and do, we will go ahead and do fire string equals fire string dot slice water bomb, passing in the water bomb width here. And then at the end of this while loop, we'll do water bombs used ++ here. All right, we're going to go ahead and do a console.log at the end of this while loop here, just to see what our fire string looks like after all this here. All right, I'm going to go ahead and grab this from our the examples in the Kata instructions here. I'm going to do a console.log here. Water bombs. And we're going to pass in this string here. And we're going to pass in a width of 2. And we're going to go ahead and punch this in the node to see what this looks like. I think that is working just fine here. It's returning 5. That is what we want to see. How about this other string here? X, 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 capital Y, X, Y, X. And we'll pass in a width of 5 here. Do we get the number 3? Yes, we do. Alright, I think I am ready to punch this into Codewars to see what this looks like here. Might get rid of this. Actually, maybe not, because we have a problem here. Alright, okay, let's go ahead and pass in a width of 4 here. Alright. Okay, I think I know what's going on here. We need to account for an instance where the next building index is actually 0. That is, the capital Y is the very first character of our fire string thus far. So if next building index is equal to 0, we're just going to go ahead and fire string slice that one character out here, and then just go ahead and hit continue here. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And that tells me we are dealing with an infinite loop here. Yup. Because we are not reassigning that string here. Let's go ahead and fix that up here. And those tests passed. Let's go ahead and hit attempt. And we are good on that. That concludes today's warm-up segment. I will see you in the next kata. Mr. Safety loves numeric locks and his Nokia 3310 cell phone. He locked just about everything in his house. He is so smart that he doesn't need to remember the combinations. He has an algorithm that he uses to generate new passcodes on his cell phone. And we are going to crack those numeric locks. The goal of this kata is to write an algorithm to open his numeric locks without his cell phone, given a string representing the thing that we want to unlock. The goal is to return a pin, a string of numeric digits that represents the code that he uses to for his numeric locks here. Let's go ahead and get started with this one here. Unlock, we'll have our string right here. Now, I want you to pay close attention to the dial pad on this cell phone here. And maybe the dial pad on your cell phone here. Have a look at the numeric buttons on there. The numeric buttons on any phone will usually have a group of letters that are assigned to it. Like, the 2 button is assigned to the letters A, B, and C. 3 is D, E, F. 4 is G, H, I. 5 is J, K, L. 6 is M, N, O. 7 is P, Q, R, and S. 8 is T, U, V. And 9 is W, X, Y, and Z. And I want you to have a look at one of the examples in the kata instructions here. I'm going to go ahead and console.log it here. I'm going to do unlock. I'm going to pass in the string Nokia here. And according to the Kata instructions, this is supposed to return the number 66542. Remember I said the 6 number is assigned to the letters M, N, and O. The 5 is assigned to J, K, and L. The 4 is assigned to G, H, and I. And the 2 would be assigned to A, B, and C. Starting to notice a pattern here? Let's go ahead and crack it here. Let's go ahead and... I think we'll go ahead and do an array here. Const result, or const key, we'll do put blank strings here. Or rather, what actually we'll go ahead and do is, I think it might be better suited to an object here. Yeah, I think what we'll go ahead and do is... go ahead and keep track of our digits here. Then we'll go ahead and iterate over each character of our string here. For const char of string.to lowercase. And then what we'll go ahead and do I think we'll go ahead and use an object for a key here. ABC, set that equal to 2. DEF is 3, GHI is 4, JKL is 5, MNO is 6, PQRS is 7, TUV is 8, and WXYZ is 9 here. Then what I think we'll go ahead and do here is do constant digit. I think we'll set that equal to do const key. I think we'll rename this keys, and here we'll do the const key, and we'll set that equal to object.keys and then find. We'll run that resulting array through find. In the predicate function will return true if k.includes char, I think. Yep. I'm gonna go ahead and console.log that key here just to see what that looks like. I'm gonna run this through node here. MNO, JKL, GHI, and ABC. And that is what we want to see here. Using that, what we'll go ahead and do, we'll do result, or rather digits dot push. I'm gonna push in the keys at key here, and then we'll go ahead and just return those digits here. join together. Do parse int digits.join with a blank string separator here. And as a result, we get 66542 for our return when we pass in Nokia. What about toilet? Well, toilet humor. And we get 864538. I think we are ready to punch this into Codewars to see what this looks like here. Copy. I'm gonna paste this in here, run the tests. Oh, this is supposed to be a string. Ah, okay. Yeah, this is supposed to be a string here, so there's no need for this parse int here. Whoops. I'm gonna get rid of that. And let's go ahead and copy this over here. Let's run the tests. And we are good. This Kata solution makes use of the object.keys function and the arrayObjects_find method. First, the object.keys function takes an object as a parameter and returns, as an array, all of the properties on the top level of that object. So, for example, what if we had an object with the properties name and age, and we pass this into the object.keys function? The function will return an array with the strings name and age. Now, for the find method. The arrayObjects_find method takes at least one required parameter, and that is a predicate function. The predicate function can take up to 3 arguments: the element being worked on, the index of that element, and the array containing that element. And the find method will return the first element of that array that would cause the predicate function to return true. So, for example, given the array of numbers 1, 2, 3, 4, and 5, if we ran this through the find method with the predicate function that would return true if element modulo 2 is equal to 0, that is, element is an even number, this find method would, as a result, return 2, because 2 is an even number, and that would cause our predicate function to return true. Now, if you ran an array through the find method with a predicate function that would not return true for any of the elements, null would be returned as a result. Here, we are the manager of a pizzeria, and in an attempt to boost sales, we have devised a reward system. If you made at least 5 orders of at least $20, you get a free 12-inch pizza with 3 toppings of your choice. What are your 3 favorite pizza toppings? Feel free to let me know in the comments section below. The reward system, however, is subject to change in the future, so the goal of this kata is to write a function that, given an object of customers, a minimum number of orders, and a minimum order value, returns a set of customers who are eligible for that free pizza. The customers in the dictionary will be represented as an array of the order values as integers here. Let's go ahead and get started with this one. We have our const pizza rewards. We have our customers, which will be represented by an object. The minimum order total count, actually, and the minimum order price. Minimum order count and a minimum price here. Alright, what we're going to go ahead and do now, going into our test here, our customers object is going to look something like this. Const, where the name of the customer is the key of the object, and the prices of the pizzas they ordered, the prices of their orders are represented by numbers and integers in an array. Now, what we're going to go ahead and do, we're going to go ahead and create, I think we could, well, run this through the reduce method here. So what we'll go ahead and do, I think we'll do object.keys, pass in our customers here. And then we'll take that resulting array and run that through the reduce method here. And then we'll set our initial accumulator to an empty object right here. And we'll call that object accumulator eligible right here. Now, what we'll go ahead and do, we're going to take our customers here, pull our customer name from the customers object here, and we'll iterate. So what we'll go ahead and do, const eligible orders, and what we'll do is we'll do customer, take the array from the customers object at this key, and we'll run that through the filter method. Now, at least $20. Okay, so what we'll do, we'll pass in the order into that predicate function here, and we'll return true if that order is greater than or equal to the minimum price here. And then if our eligible orders is greater than or equal to our minimum order count here, we will go ahead and add that customer to our minimum order, our eligible customers array here, or rather object. And it, as our initial accumulator, actually needs to be an array. So let's go ahead and pass in that customer here. Otherwise, we'll just go ahead and return our eligible array unchanged here. All right, let's go ahead and test this out here. I'm going to do a console.log down here. Pizza rewards. I'll pass in our customers object that we created up top here. I'm going to pass in for the minimum order count 5 and the minimum price 20. Let's run this through node to see what this looks like. And we get an empty array, and we do not want that here. Alright, let's see where we're going wrong here. Console.log, eligible, and customer. Because they're not doing dot length in our eligible orders here. And Jane Doe here will be eligible for a free pizza in this circumstance here. Alright, I think we're ready to punch this into Codewars to see what this looks like here. So I'm going to take our function here, copy, paste that in here. Let's go ahead and hit attempt, and we are good. Save for the use of object.keys in this Kata solution, there really isn't much for me to say about this one, so I'm going to go off on a little tangent instead here. I'm more of a supreme pizza, meat lovers kind of guy, but if I had to pick my 3 favorite pizza toppings, it would have to be sausage, pepperoni, and jalapeno. I really love those hot peppers here. I'm also a fan of pineapple on pizza as well. I never really got the hate behind that here, so let me know what you think about pineapple on pizza in the comment section below. Steve and Josh are bored and want to play something. Now, they don't want to think too much, so they come up with a really simple game. The goal of this kata is to write a function to determine who is going to win. Here are the rules. Steve and Josh are dealt the same number of cards. They both flip the card on top of their deck. Whoever has a card with the higher value wins the round and gets 1 point. If there is a tie, if the cards are of the same value, no points are awarded. After this, the 2 cards are discarded and they flip another card from the top of their deck. They do this until they have no cards left. Deck Steve and Deck Josh are arrays representing their card decks. They are filled with cards represented by a single character. Their rank is as follows from lowest to highest. Look in the kata instructions here. We have the characters 2, 3, 4, 5, 6, 7, 8, and 9. T for 10, J for Jack, Q for Queen, K for King, and A for Ace. Every card may appear in the deck more than once. We have to figure out who is going to win and return a string representing who wins and with what score. Alright, let's go ahead and get started with this one. Have a look at this example right here. Steve is dealt an ace, 7, and 8, and Josh is dealt a king, a 5, and a 9. In the first round, the ace beats the king, and Steve gets a point. In the second round, the 7 beats the 5, and Steve gets a second point. And in the third round, 9 beats 8, and Josh gets his first point. So, in that example, we should return the string Steve wins 2 to 1. Alright, let's go ahead and get started with this one here. Const winner equals, we'll have our 2 parameters here, deck Steve and deck Josh. So, what we'll go ahead and do, it can be assumed that these arrays will have the same exact number of elements here. So, what we'll go ahead and do, we'll do for let I equal 0, I is less than deck Steve dot length plus I. We'll have this for loop right here. We'll keep track of our score here. Let points score Steve equals 0. Score Josh equals 0 here. And I think we ought to go ahead and keep track of our cards here. We'll do const ranks, and we'll go ahead and grab these characters here in our kata instructions and stick those inside of an array here. Alright, what we'll go ahead and do here, I think what we'll go ahead and do is if const rank Steve equals ranks.index of deck Steve at index I here. And then we'll do the same thing for Josh's card here. And then if rank Steve is greater than rank Josh, we'll do score Steve plus here. Else if rank Josh is greater than rank Steve, we'll do score Josh plus right here. And remember, no points are awarded in the case of a tie. Alright, now at the end here, what we'll go ahead and do is, we'll do if score Steve is greater than score Josh, we'll return a template string that says, let me scroll down here, Steve wins. And our first placeholder will do score Steve 2, and then the second placeholder score Josh. Then else if score Josh is greater than score Steve, we'll return Josh wins score Josh in the first placeholder to score Steve in the second placeholder. Otherwise, if the scores are the same, we'll return tie right here. Alright, let's go ahead and go down to these tests here. I'm going to grab this array here. I'm going to do a console.log down here. And go to simple card game. And we get the string Steve wins 2-1, which is what we want to see. Alright, let's go ahead and punch this into Codewars to see what this looks like here. And we are good. Sticking with the theme of card games here, a somewhat more complex card game that Steve and Josh could have played is the game of Blackjack. The game of Blackjack is scored as follows. Numbered cards count as their face value, 2 points through 10 points. The Jack, Queen, and King count as 10 points, and the Ace can either be counted as 1 or 11. The goal of this kata is to write a function which receives an array of strings that represent each card in the hand and returns the score of that hand in the form of an integer. That score should be the highest score of the cards that is less than or equal to 21. If there are no scores less than or equal to 21, then we should return the smallest score that is more than 21. Alright, let's go ahead and get started with this one here. Got score hand, and we'll have our cards right here. Now, what I think we should do here is I think we'll go ahead and keep track of a score here. And that is going to be what's returned here. I think we'll go ahead and iterate over our cards here. Const card of cards. First and foremost, if our card just in case, card equals card.to uppercase. If card is equal to the ace, we'll have 3 separate if blocks here. Or rather, maybe a switch statement here. Get rid of this up here. Case A. Case Jack. Case Queen. Case King. And then a default case down here. Now imagine there could be some invalid inputs here. The kata instructions doesn't say anything otherwise here, I don't think. So for our default case, what we'll go ahead and do, we'll do score plus equals parse int card here. And then for our Jack, Queen, and King, our score should be incremented by 10. Need to add break statements here. And then for the ace, it's kind of going to be somewhat of a different beast here. If score plus 11 would take our score greater than 21, then we need to go ahead and just do score plus plus here. Otherwise, we'll do score plus equals 11 here. All right, let's go. Let's go ahead and test this out here. I'm gonna go ahead and grab this ace down here. I'm gonna do a console.log here. Score hand. I'm gonna pass this ace in here as the sole element of our array here. I'm going to do a node Blackjack Scorer, and that gives us 11 here. Let's go ahead and add in our jack here. And that should give us 21. Now, what if we had an ace, a 10, and an ace? That would give us 22, and we do not want to see that here. All right, I have a new idea here. I'm going to go ahead and wipe this clean here. And what we're actually going to go ahead and do, we're going to take our cards and we'll do const card scores, and we're going to run that cards array through the map method here. Then what we'll go ahead and do here, switch card to uppercase. We'll do here case A for the ace. No. No, that ain't gonna work. And we can do all that here. What if I tried doing a sort here? I'm going to go ahead and comment all this out here. Oops. What if we tried doing a sort here? Return cards, not sort. We tried sorting all of our aces to the end here. A is equal to the ace. Working on a little bit of a hunch here. Why don't we grab this hand right here? This is liable to involve some sorting here. We probably won't. Yeah, we probably are going to need to sort our aces out to the end of the string here. I have an idea. What we'll go ahead and do is we'll have a couple of arrays here. I'm going to run our cards array through the reduce method. And then what we'll go ahead and do, if our card.toUppercase is equal to the ace, we'll go ahead and do sorted at index 1 dot push card. Or rather, return sorted I think this would actually be better off as an object here. So what we'll go ahead and do here, turn sorted Alright, I have a new idea here. Const non-aces equals cards. Dot filter card. Card is not equal to the ace. And then we'll do const aces equals cards dot filter card. Card is equal to the ace. And then we'll concatenate those together here. Cards is equal to non-aces and then aces. Then we'll go ahead and actually just go ahead and return our cards as is here. And that should go. Alright, what we should be able to go ahead and do now is we'll go ahead and keep track of a score. And we'll do just as we did before with the for loop here. For const card of cards, switch card dot to uppercase, case A for the ace, if score plus 11 is greater than 21, then score plus equals 1, else score plus equals 11. And then we'll have a break here. Case jack, case queen, case king, score plus equals 10, break, default, score plus equals parse, int card. Break here. Let's see what happens here. And we get the score of 25 for this particular hand. Alright, let's go ahead and revisit that ace 10 ace here. And we get the score. Damn it, we still get the score of 22. And we still don't want that. Alright, new idea here. While cards.length is greater than 0. And then we'll do const card equals cards.shift. Shift that first card out of that array. And then 21. And there are no more cards. Oh, that just breaks it even more. Alright, let's go ahead and console.log that here. At the end of this while loop here, console.log the remaining cards, current card, the remaining cards, and the score. Alright, I have another idea. Let's go ahead and get rid of all this here. Alright. Yeah, keep track of our score here and return it. Actually, we'll go ahead and make that an empty array here. Let's go ahead and iterate through our cards here. Const card of cards. Switch card. Case ace. Scores dot push 11. Case jack. Case queen. Case king. Scores dot push 10. Break. And then default scores not push parse int card break. And then we'll just go ahead and return our scores here. 10, 11, 10, and 11. Then what we'll go ahead and do, let's go ahead and sort those scores in descending order. So we should get 11, 11, and 10. And then while scores that reduce val plus a val is greater than no, that ain't gonna do. Scores dot reduce ec val plus ec plus a val. We need this to produce 12 here. I have an idea here. Let ace index equal -1. We'll do a do loop or while do an ace index while kind of score some. How about we try this? And then while score some cause ace index scores dot index of 11, and while score sum is greater than 21 and ace index is not equal to -1. We'll go ahead and change the index of our scores array at the ace index. Change that to 1 here. And then we'll go ahead and do a let here instead of a const. We'll actually need to make this a let as well. And then take our score sum, subtract 10 from that, because 11 minus 10 is 1. And then we'll recalculate our ace index here. Scores our index of 11. And then finally, we'll go ahead and return this score sum down here. And as a result, we do get that 12. All right, let's go ahead and bring this other array back here. And we still get the score of 25. Okay, I think I'm ready to punch this into Codewars to see what this looks like here. And we are good. I enjoyed this one. Now this was something of a brain buster that really got me thinking here, and I like those kinds of challenges here. I could have implemented this one quite a bit better, however, by saving the calls to reduce an index of, instead of an array keeping track of each of the individual card scores. I could have just used an integer to keep track of the number of aces we had in our hand here. and for each ace that we come across, increasing our score initially by 11 points, just as we did in our Kata solution here. Now, at the end, if we had a score over 21 and we had a number of aces that was greater than 0, we could have used a while loop to subtract 10 from our score and 1 from our ace count. And in so doing, we would be able to do away with our array of card scores, and thereby our cause to reduce an index of, resulting in quite a more performant Kata solution. And that is going to do it for today's episode of Versus Codewars. If you like this video or you learned something new, drop a like and subscribe to my channel to see me take on more coding challenges on Codewars. As always, if you think there is anything I can do to improve on my code for the better, feel free to drop a suggestion in the comments section below. Also, if you are a Kata author on Codewars and you would like to share your authored katas with me, feel free to drop links to those katas in the comments section below, and you might see me take on those katas in a future episode of Versus Codewars. I hope you have a wonderful and safe day, and I will see you on the next episode of Versus Codewars.